All right, so I saw a lot of people go through this, just kind of jump straight to the pictures without completely getting um, a. You jump straight to the illustrations without getting a clear mental picture of what's going on in this problem number 9. And we're moving on to forces. So just to be clear, what we're saying is that these are little drops of oil that the car is leaving behind, and they're happening one after the other with the same amount of time in between drops. So for example, this would be at 0 seconds, this would be 1 second, 2 seconds, 3 seconds, 4 seconds, 5 seconds. And so what that tells us here is that the spacing between the drops is increasing, which means the car is changing its speed. It does have an unbalanced force. So I want to be really clear here. Not only is the car changing speed, but let's be really clear that it is speeding up. Okay, just to be absolutely clear. Now here the forces are completely balanced because it's moving at constant velocity. And lastly, here we're starting off going really fast because the distance between the drops is big, so it's traveling a big distance in a little time. And then since the time between the drops remains absolutely the same, so this would be with second number 1, 2, 3 seconds go by, 4 seconds go by, 5 seconds go by, 6 seconds go by, 7 seconds. Each second that goes by, I'm traveling less distance. So I'm still changing speed, but I'm slowing down. And so the forces are in fact unbalanced. Now, based on these dot diagrams in question 2, we can match them to free body diagrams that correspond to the forces acting on the car. So let's be clear. I think the fact that B is moving at a constant velocity and the forces are balanced to make this dot diagram the clear winner for B. However, let's look at A. A is changing speed and it's speeding up, which means the net force goes to the right. And that's why I'm choosing A for the second one. That makes our leftover one C, but let's talk about why. So it's moving forward and slowing down, which means the net force has to be to the left because it's trying to stop it from moving to the right. All right, so if a net force acting upon the object is 0, this is just a fancy way of saying that the forces are balanced. So let's remember, with balanced forces, we are either at rest or we're moving at constant speed in the same direction, which is the same as constant velocity. So that means choice E, either E or D, is the correct answer. So that's a good look at questions 9 and 10.